The data passed every check in the ordering system. It was valid, accepted, and confirmed. Then it arrived in the inventory system and was rejected. Same data, same rule, different answer. This is not a bug in either system. Both systems were working exactly as designed. The problem is that they were designed independently, with rules that looked identical on the surface and behaved differently in practice. In a single database, a constraint is a boundary. In a distributed system, a constraint is an agreement, and agreements can fall out of sync. Imagine a country with two neighboring cities, each with its own building code. Both codes say structures must be able to withstand winds of up to 120 kilometers per hour. That sounds like the same rule, but one city measures wind speed at ground level. The other measures it at roof height. A building that passes inspection in the first city fails in the second, not because the standard changed, but because the two cities were measuring the same thing differently. The rule was shared in name, it was not shared in meaning. This is exactly what happens when constraint logic is duplicated across systems. The rule is copied. The implementation diverges. Nobody notices until data crosses the boundary. In 2020, a European e-commerce platform completed a transition from a monolithic application to a microservices architecture. The original system had a single validation rule. Product descriptions must be between 10 and 1,000 characters. When the product catalogue service and the search indexing service were built as separate components, both teams implemented this rule independently. The catalogue service enforced a maximum of 1,000 characters, measured in characters. The search indexing service enforced the same maximum, measured in bytes, using UTF-8 encoding. For standard ASCII text, one character is 1 byte. The two rules produced identical results. For product descriptions containing accented characters, emoji, or non-Latin scripts, common in a platform serving 8 European markets, a single character could occupy 2, 3, or 4 bytes. A description of 950 characters that included product names in Greek, Polish, and Swedish passed the catalogue service without error. It was rejected by the search indexing service as exceeding 1,000 bytes. Over 6 weeks, approximately 14,000 product listings were accepted by one service and silently dropped by the other. The products existed in the catalogue. They were invisible in search. The revenue impact from unindexed listings was estimated at 290,000 before the divergence was identified and corrected. The rule was the same. The measurement was not, and in a distributed system, nobody was watching the boundary between them. This is the defining characteristic of constraint scope failures. They do not produce an error at the point the data is written. They produce an absence, a missing record, a silent drop, a gap in a downstream system that takes weeks to notice. A constraint violation in a single database throws an exception immediately. A constraint divergence between two systems produces nothing. The data just stops. Constraint scope problems emerge from 3 sources. The first is independent implementation. 2 teams write the same rule separately, and the implementations drift from each other over time as requirements change. The second is schema evolution. One system updates a constraint, and the corresponding system is not updated to match. The third is environmental difference. 2 systems enforce nominally the same rule, but using different libraries, different locale settings, or different underlying data types, so edge cases resolve differently. There are 3 things that address this. First, treat cross-system rules as contracts, not copies. When the same constraint must exist in 2 systems, it should be defined once, in a shared schema registry, a shared validation library, or a shared specification document, and consumed by both. A rule that is copied is a rule that is already on its way to diverging. A rule that is referenced from a single source cannot silently split. Second, test the boundary, not just each side. Most testing verifies that each system handles its own inputs correctly. The failure point is the data that crosses between systems. Build integration tests specifically for data that lives at the edge of a constraint, the values that are just inside the limit, and the values that are just outside it. Run those tests against every system the data will pass through. A description of exactly 1,000 characters in UTF-8 with non-ASCII content should have been in every test suite on that platform. It was not. Third, instrument the gaps. In a distributed system, silent drops are more dangerous than loud failures. When data is accepted by one service and not written to another, that absence needs to be detectable. Reconciliation jobs, count comparisons, and audit logs between services are not optional complexity. They are the monitoring layer that makes constraint divergence visible before it becomes a 6-week revenue problem. The two neighboring cities both had building codes. Both codes were real, both were enforced, and both were followed correctly within their own jurisdiction. A building that met the first code was rejected by the second. The contractor standing at the boundary, watching a structure that passed every inspection fail the next one, was not dealing with a failure of enforcement. They were dealing with a failure of coordination. The rules had never been reconciled with each other. In a single system, a constraint is a boundary the data cannot cross. In a distributed system, a constraint is a promise every system makes independently. Promises made independently are only as reliable as the coordination between the people who made them. When that coordination breaks down, and in every sufficiently complex system it does, the data crosses one boundary and stops at the next. No error, no exception, no indication that anything went wrong, just a gap where the data used to be.